In this particular lecture series of stereographic projection, we are going to see the stereographic projection from the point of view of crystallography. Today, in this particular session, we'll try to see some basic aspect of the stereographic projection. So, the first of all, one of the most important thing for the crystallographers is that they work upon the obviously crystal, and crystal has stored a lot of symmetry in it. And if someone want to preserve that symmetry, it cannot be done by orthographic projection or any other projection. It can only be done by stereographic projection. Why is it that? It's because stereographic projection are the angle to projection. So it is going to preserve the angle, and so it will preserve the symmetry, and so its study is very important from the point of view of the crystallographers. Okay, so now what is stereographic projection? First of all, what is projection itself? Let us say this is my hand, and what this light source is doing, that it is projecting my three-dimensional hand onto the screen. Okay, this shadow is projected upon this particular paper, which is two-dimensional. So my three-dimensional hand is projected as a 2D. So this is what the typical projection will do. So it will take us from three-dimensionality to the 2D. We know the crystals, right? So the crystals, when we usually study the crystal, let me draw one. We usually deal with the plane and we deal with the direction. Right. Now, plane is one having a dimensionality of 2D. So in real space, if I project, if I do the stereographic projection of it, see the three dimension is converted to the two dimension. So the two dimension will convert to the one dimension. What about the directions? Direction is one dimension itself, and it will convert it to the zero dimension. Zero dimension is nothing but a point. So the all the projection of the direction will get as a point, and the projection of the plane will get as a one dimension curve. Okay, so this was some basic aspect. This was from the point of view of the projection. We have not discussed the stereographic projection yet. So let's just see what it is. We'll start with the sphere. We'll see the construction of the stereographic projection first. This particular sphere which we have drawn, it is known as the reference sphere. Let me mark it somewhere. Now, What I will do, I will put one crystal over here at the center of this particular sphere. And again, at the center, I will put one light source. Okay, so what this light source will do, it will radiate light in all the directions. So we can say that each ray of the light will represent a particular direction itself. Okay, because we know in the crystals, we are having the set of the directions which we have to deal with. Let us say it's H, K, and L. Now, let's draw that particular direction. Let's say this is a particular direction which is of our interest. It's going to, this particular line, this particular direction is going to intersect our sphere in some particular point. Let us say it's point this A. Now, let us say this is our north pole and this is our south pole. What we'll do, this intersection point of reference sphere and the direction, this point, will join with one of the two. Let us say south pole we are joining with. Wherever this particular line is going to intersect our primitive circle, I forget to tell the name of this horizontal circle. Like if I take a sphere and I cut it just in between them, like two equal part I am taking out, then this particular thing is known as this horizontal circle is known as the primitive circle. Now wherever this particular line which we have drawn is going to intersect the primitive circle, that will be our projection. And we know that this line and the circle can intersect only at the one point, and so this is representing the direction, the projection of the direction. We have seen that the direction has converted to the point. A 2D, sorry, a 1D object has converted to the zero dimension. So the procedure is very simple. A light source will be there, it will go in all the directions, particular direction, let's say this particular ray is representing one of the direction, and wherever this particular direction is going to intersect with the reference sphere, that particular point will join it with the one of the pole. And that line which we have just found, wherever it is going to intersect the primitive circle, that will be our stereographic projection of particular direction. Now one can draw this primitive circle itself. It will be of the same radius. This particular circle, let's say this is center O, this will also be center O. And we have presented that particular point A, which is going to intersect somewhere over here. Let's say this particular point is A dash, and this will be A dash. And that's how we have converted the particular direction, and this is our stereographic projection of a particular direction, direction A. Now we can stop it over here, and in next lecture we'll discuss about some general directions, and we'll try to find how we can represent those directions in this particular primitive circle. Okay, and in upcoming week, in upcoming lecture, what we'll do, we'll see how we can plot the stereographic projection in the wolf net. We get familiar with that, how the wolf net is, what kind of construction does it hold with itself, and how to use it first of all. And also we will try to answer that is someone, let us say someone is not having the wolf net with them, is it possible that they can still do the stereographic projection? So the answer is to certain extent yes. And we'll also try to solve few questions, some tasks where we will use WolfNet, and we'll also solve the same task where without using the WolfNet we will be able to find the projection or complete that particular task. Okay.